Coulomb's law. Let us work out some more problems. The problems are polygon type numerals. This is the one I did it in the previous class, the same type, but problem is different. What is the problem? The problem is there are three charges in the space. The geometry of arrangement is vertices of the triangle. The triangle is equiangular, equilateral. That is, all angles are equal, all sides are equal. Equiangular, equilateral. The vertices are A, B, C. The charges are arranged at the vertices. The charges are plus Q, plus Q, plus Q. Same magnitude, same same sign, plus. And this is the arrangement of the charges in the space. And asked to calculate what is the net force acting at this point, acting on this charge. These charges are point charges. So this is what asked. Let us first get the mathematical formula for the net force acting at this C, at the point C. First understand what are the interaction of this charge with the other charges in the space. The other charges are this and this. The interaction is between this charge and this charge. There is a force of, what is that? Coulombic force, of course a repulsive force, because carries plus charge, plus charge. The repulsive force is F2. That is the direction of the force. That is away from this point, repulsive force. And one more force is acting at this charge. It is by this charge. Again plus repulsive force. That is the force acting at this point along the line. And the direction is this. Repulsive force away from this point. Repulsion between this and this. Repulsion between this and this. And there is also an interaction between this charge and this charge. This will have no effect on this, because in accordance with the the principle of superposition, no effect of this interaction on this. Only it is a interaction between this charge and this charge. The force acting at this point is this force, and the force acting at this point is this force. This is the direction of this force. The net force at this point is, it is the vector sum of these two. Vector sum of these two. That is F1 and F2. Let us write what is F1 and F2 in accordance with the Coulomb's law. The force between this point and this point, that is charge at this point is plus Q, at this point is plus Q. That is in accordance with the Coulomb's law. F1 or F2, this one, F2 is equal to, that is Coulomb's constant into charges, charge into charge, plus that is Q into Q square by A square. The distance of separation is A. That all sides are same. Similarly, the force of repulsion, that is the force acting due to this is, it is F1, K into Q square by A square, because same charges, same length. So these two forces, F1 is equal to this, F2 equals this, because these two forces are same, equals F. So these are the forces. The net force at this point is vector sum of these two forces. What is the vector sum of these two forces? Using this formula, we can sum up these two vectors, because this is the kind of, for this kind of vectors, we use this formula because they have differ by this angle, some angle you always use this formula already used in the previous class. Repeat the same thing. That is, resultant or net force at this point is, this is the one, it is equal to root of this plus this whole square, the square plus 2 into this into cos theta angle between these two vectors. Now substitute the for this equation, F1 is equal to F2 equal, that is the same, F1 equals F2 equals F, both are same. So let us call this as F, and theta is equal to 60. So the equation becomes, this is a 2f square plus 2f square plus cos 60. We know the value of cos 60 1 by 2. So simplify the 2 to cancel, f square. So in the root we have 2f square plus f square equal 3f square. So fr is equal to root 3f, that is square cancels root 3f. So resultant at this point is fr, that is root 3f. So root 3f means what is the value of f, what is the formula of f? F is equal to kq square by a square, kq square by a square. So the resultant at this point, the resultant at this charge is root 3 into kq square by a square. That is the formula for this symbol. So if you know the formula, once we know the formula, we can write what is that, any force acting at this point, if you know the values for these symbols. That is, you are given a set of values for q, that is q is equal to, the problem is given, this is the amount of charge, it is same at all vertices, and the distance, which is distance between the charges is 0.1 centimeter. So with this set of values, what would be the net force? For that you need to substitute that into the equation. So root 3 into k, the k must have known to you, 9 into 10 to the power of 9, that is in SI unit, and q square, what is q? 50. It is in micro coulomb, so write it in coulomb, SI unit, 10 to the power of minus 6, whole square is the whole square, whole square. And a square, what is a square? A is equal to 0.1 centimeter, should be in meter, substitute for c, c is centi, 10 to the power of minus 2, 0.1 10 to the power of minus 2 whole square. Then simplify this, taking all the exponents of 10 together, numerator and denominator, it reduces to 10 to the power of 5, that is plus and minus. Finally we have 10 to the power of 5 exponentials of all exponential of 10 reduced to 10 to the power of 5. Simply having the remaining is root 3 into 9, that is 5 into 5, 25. So when you multiply this, you get 389.7 10 to the power of 5 Newton. What is this? This is a net, that is Fr. What is Fr? That is the direction of the Fr. So what is the magnitude of Fr? The force, net force acting at this point where the charges is residing is 389.7 10 to the power of 5 Newton. So this is how you can solve this type of problem. Next is, next second problem is, there are 4 charges in the space. Here are 3 charges in the space. There are 4 charges in the space. What is the geometry of arrangement? The geometry of arrangement is vertices of square. It is triangle. There are 4 vertices. This is square. What is square? All sides are equal, all angles are equal. 90 degree, 90 degree, 90 degree. All sides are equal. So geometry of that is given problem. Geometry of the arrangement of the charges are this, plus q minus q minus q plus q. The magnitude of the charges remains same. Here all this carry plus, this will carry minus. There is only difference. So now the problem is asked, what is the net force acting at this point, that is on this minus q, at this point C, net force. For the net force at this point, first we should see with charges, it is giving interaction. There are 3 other charges, so it must have interacted with this charge and this charge as well as. So that is the force acting between this and this is F1. The direction is mentioned. What is the direction? Because plus and minus attract means this is a direction, it is moving towards this. So this is the direction of the force. That is F1 is the Coulombic force of attraction between this point and this point. Similarly, what is the Coulombic attraction between this point and this point? Plus minus. This attraction means that is the direction of the line along this line. And the force is F2. That is F2. That is a interaction, Coulombic interaction. And what is the interaction between this C and A? Here A and C. So it is a straight line, always interacting along the straight line. So plus Q and minus Q, again the attraction. That is the direction, that is F3. It is moving this. That is F3 is the Coulombic force between this point and this point, is the direction F3. So there are 3. There is also interaction between this charge and this charge, as well as this and this, as well as this and this. This interaction will have no effect on this charge because of principle of superposition. That what is the condition? So now what is the net charge at this C? At the point C is, that is at C is equal to F1 plus F2 plus F3. What is F1? F1 plus F2 plus F3. These are the interaction forces acting at this point. It is a vector sum. Should be vector sum of this plus this plus this. That is net force of this. And we calculate what is F1, F2, F3. That is F1 is equal to F2. Equals F2. Both are same. This F1 is equal to F2 because same charges, same distance of separation. K q square by a square. That is K into q square by a square. Same as q square by a square. F. F1 equals F2 equals F. That is same. This is the equation for this. So what is the equation force F3 for F3 between these two? It is again what is the Q into Q square, K Q square divided by distance of separation. Distance of separation is not A, it is the diagonal of the square. You know diagonal that is diagonal of the square is root 2A. It is, we get it from what is that? Pythagoras theorem. We get this value by knowing this one. Using Pythagoras theorem, we get the distance. What is the length of this diagonal is root 2 into A. This is whole square of this. That is F3. F3. So F1 is there. Now when we sum these two, we cannot sum all the 3. First we sum any 2, then resultant and this sum. You will like that. 2 only, we have to sum it. Sum of the forces or the vectors. So what is the vector sum of these two using the same formula? F1 is equal to F2. Angle between these two is 90 degree. F1 and 90 degree, cos 90. So F1 equals F2 is the same form. This is the one you get. This is F4. You know what is cos 90? Cos 90 is 0. This becomes 0. Second term. So only 2x square remains. So it is 2x square means root 2f. That is F4. F4 is equal to root 2f. What is F4? F4 is along the same line. That is the resultant of these two is same along and it is along the same direction as F3. Look at this. This is the direction. So here on this line there are two forces are acting. It is a resultant of these two and the force, Coulombic force between this and this. F4 and F3. So F4 we know that, substitute that into that. So again you can sum these two. There are two vectors and vector sum of these two. What is vector sum of these two? So there is no angle, angle is 0, it is on the same line. Then the vector sum is just the sum of these two vectors. That is this vector plus this vector. Angle is 0. That is why I gave no. Just summing of these two, root 2f plus k q square by 2a square, that is f3. Then simplify f net force at this point C, net force acting at this point C is equal to, simplify this root 2, what is that? This f, substitute for f is equal to k q square by a square, root 2 into this, and taking LCM and simplify, that is k q square by a square is common factor into root 2 plus half. That is a final formula. That is, what is the mathematical formula for these impulse for the net force at this C. So with this formula we can solve for any problems for any set of values given over there. Here the values are given here. Find the net force at C. If the values given are any values you can take, or they can give in the examination. Q is equal to 1000 micro coulomb, A is equal to 10 centimeter. That Q value is given, A value is given. For any set of values we can work out a problem. We can solve the problems. So just substitution for this. E net, what is it? F net is equal to K means you know the value, and Q square means the given as 1000 in 10 to the power of minus 6 whole square into coulomb. That's value, that is numerical value remains in bracket, and A square is, what is that? 10 in 10 to the power of minus 2 whole square. Simplify. First simplify with all exponents of 10, reduce to 10 to the power of 5. This is 9 into, this is, sum of these two is 0.702. Multiply this, you get this final value. That is net force acting at this point for this set of values. It is 6.36 into 10 to the power of 5 Newton. So this is the steps we follow. First get the mathematical equation for these symbols, and you can go for solving the problems. And the next problem is, there are 5 charges in the space. There are 5 charges in the space. What is the geometry of arrangement of those charges? Geometrical arrangement is, again, it is the vertices of this square. 4 charges are at the vertices of the square, and one more charge at the center of the square. The charges are plus q, minus q, plus q. Same magnitude of charges. These have plus and this is minus. And the center of this square, there is one more charge, it is q. This value is different. Plus q. Q is different. So you have to calculate what is that. The problem is this. The point, this point is E. You have to evaluate or find out what is the net force acting at this point by all these charges. That is the one, the problem. The net charge acting at this center of the square by all these charges, the point has this charge. This is plus q. So net charge means what are the interactions. First you see that what is the interaction in this charge. There are 4 other charges are there. So it can have interaction with 4, what is that? 4 different interaction, 4 coulombic force of attraction between this and this, between this and this, between this and this, between this and this. Between this and this, the force is F4. That is the direction, because it is plus q and plus q. That is a repulsive force. That is, this is a repulsive force. Let's see what the force means. This is the force between this charge and this charge. Plus q, repulsive. That is the direction of the force. Repulsive means that it is moving this direction. This is the force F4 is acting at this point between this q and this q. The interaction between this charge and this charge, that is the force F4. Direction is this straight line. And between this charge and this charge is, that is F3. Direction is this. Repulsion means this point is moving away. That is the direction. The line, same line, 2 forces this point. Here plus minus attraction. Attraction means it is moving towards this. That is what is one? F. That is F2. This and this. F2 is this and this. And there is an interaction between this point and this point is again what is that? It is a repulsion. Repulsion means the point is moving away. That is the direction of the force, F1. So F1, the direction, F2 directions are same line. They are combining. So F1 and F2, the forces by this charge between this charge and this charge. This is the direction and F1, F2. There are 4 forces. And there is also in addition there is an interaction between this and this and this. These interactions will have no effect on this point because interaction of this charge with the other charge is the one net force we take. Vector sum of those two charges we take in accordance with the principle of superposition. Net force. What is the net force? So net force is equal to F1 plus F2 plus F3 plus F4. All the 4 forces. F1 plus F2 plus F3 plus F4. Net force. And F3 plus F4. Look at that. What is F3 plus F4? The force. Let us calculate what is F1, F2. F1 is equal to F2 equals F3 equals F4 equals F. All forces are equal because the charges between them, all charges are same. So it is KQ. K into Q into this by R square. That is distance of separation. R is the distance of separation. That is half of the diagonal of the square. R. KQ Q by R square. So these distances are same and this remains same for all. This remains same. That is by KQ Q by R square. All of them are equal to this one. And let us see what is F3 plus F4. F3 plus F4 same magnitude. Both are same. Same line, opposite direction. Look at that. They have same values, same line, opposite direction. Get cancelled. That is 0. Sum of these two will be 0. And what is the net force at this point? It is sum of these two vectors, sum of these two forces. F1 plus F2. F1 plus F2 vector sum means that is F1 plus F2. It is again on the same line, same direction. It is just sum of these two, F1 plus F2. F1 is equal to F, that is 2F. This also F, this also. So we don't take this one, need not take this formula. If you take this formula also you get, because angle is 0. If the angle between the two vectors is 0, it just sum of these two vectors. F1 plus F2 means F plus F is equal to F. So net force at this point, at this charge by all these charges is equal to just 2F. 2 into F. What is F? KQ by R square. So KQ by what is R? R is half of the diagonal. That is diagonal values. What is the diagonal? So root 2a. Recall that root 2a is there and the diagonal of the square. Half means root 2a by 2. It is same as what is that? A by root 2. That is when you do so, root 2 by a, root 2 a by 2 is equal to a by root 2. So R is equal to a by root 2. It is half of the diagonal, whole square, R square is there. Simplify, you get this. This will go to numerator, 2 into 2. Get this. 4k q divided by a square. What is F net? Small q and capital Q. Small q is this, capital Q is this. Net force acting at this point is 4k q by a square. What is a square? Is the length of this. So if you know this formula, that is the formula is important. Once you get this formula, you can solve what is that a problem for any set of values. This is the best set of values given here. So for these symbols we have given the values. Capital Q is equal to 100 microcoulomb, small q is equal to 10 microcoulomb, 10 microcoulomb, A is equal to 100 centimeter. Substitute for them because same equation. That is 4 into K, this K value, and it is small q, that is capital Q, the 10 in 10 to the power minus 6, 100 and A is 100 in 10 to the power minus 2, that is in SI whole square. Simplify, first simplify exponents of 10, it becomes only 1, remaining 4 into 9. So 4 into 9 is 36 Newton. That is it. With this all this we get finally 36 value. So it is a 36 Newton force acting at this point. Net force acting at this point is 36 Newton. That is the direction of the force. So with this, what is that? So this is how you can able to solve the problems like this. Polygon type numerals. Keeping in mind what is the geometry first, then what you need, what is that? The forces acting at the point. First identify what are the forces acting at this point and take the vector sum of all these. This is how we get it. And the last one more type of the problem is here third charge in equilibrium type. It means there are two charges. Two charges means the force acting always along a straight line. That is a straight line along with the interaction of coulombic force is acting. That is a charge plus q and plus 4q. The charges are in the space. So interaction is on the straight line. If one more charge, not in the space anyway, it comes along the same line, any point on the same line, we need to find out what would be the equilibrium position of that charge, third charge. What is meant by equilibrium position? The point, that is at what point on this line, this charge, the net force on this charge is 0. That is called equilibrium. Equilibrium means never move, stand still. That is acting, two forces acting in the both directions, keeping this charge at the same position without moving. That is called equilibrium position. So the type of problem, let us understand what is this problem. There are two charges, the magnitude are 4, here 1 plus q, same charges, and one more charge I am taking plus q, the magnitudes are different, here q and q. And the distance of separation of these two charges is L. Let me place this charge in between these two charges and try. What are the directions? That is why we find direction of the forces. When we keep it in between somewhere here, the force acting between these two is what is the plus and plus. The direction is repulsive. That is the force away from this point. Tends to move away from this point. That force is F2. Direction is this. And the same charge with this charge. That is again repulsive. Plus repulsive. That is it is moving away. Moving away from the point. That is F1 is the repulsive force at this point by this charge, and the direction is this repulsion. So these two forces, look at that, when you keep this in between these two, the two forces are acting in the opposite direction. So only thing we have to find out what is the point it has an equilibrium position. So for that, let us write this distance between this and this is equal to x. Let us call it as x, and the remaining is L minus L. The total length is L. Equilibrium means net force acting at this q by these two is equal to 0. That is F1 is equal to F2. What is equilibrium? Net force acting at this charge, the same line, by these two charges is equal to 0. That is F1 is equal to F2. When F1 is equal to F2, it remains fixed at this point, equilibrium position, no movement. It is attracting equally in both directions. that is the equilibrium position. Find out F1 and F2. What is F2? The coulombic force between this and this. K Q by Q x square. Distance is x square. That is Q, this is Q. Coulombic force, coulombic constant. And this one is coulombic force between this and this is K. For Q is the magnitude of charge into Q divided by the distance of separation is L minus x whole square. And equate them because equilibrium is this is the one. Solve for this. Let us see what you get. Here K, Q, K all cancel. Remaining is you can take one. Interchange. Take it to the left hand side. L minus x whole square. That is square is equals 4 remains. Whole square is equal to 4. So simplify, that is square root. Take root means L minus x by x is equal to 2. There are two possible values, plus 2 minus 2 in this case with algebra. It is square is equal to this. What is that? Root of this plus 2 minus 2. There are two possible values. For this, what is the value you get? That is L is equal to 3x, x equals L by 3. For this possible you get L equals minus x equals minus L. Both are same. Minus means here no possible, not true value. Plus value means true value. L plus 3, L divided by 3. So x equals L by 3, that is a true value, that is a one current. What is the equilibrium position? Equilibrium position is the point of this, that is the point where it lies exactly 1/3 of the L towards the smaller charge. It is the near to the smaller charge is Q. 1/3, that is x is equal to L by 3 is the equilibrium position. That is what's called. What is the equilibrium position of these two charges? That is the one L by 3. This is what you can find out. The third charge in equilibrium of this type. In the other one, problem number 5, I have taken here plus and plus. I am taking one is plus, other is minus. The value is 1q, here minus 9q. And there are two charges, the interaction is along this straight line, force of attraction is straight line. So it is away from this like this. And the third charge plus I am introducing along the line, anywhere in the point along this line. We shall find out what is the equilibrium position of this charge. Plus try placing this charge in between these two and see that two forces acting in the opposite direction. Let us place in between these two Q. This Q will attract towards this, that is direction. And this Q will have repulsion on this Q, plus. Repulsion is in the same direction. That is the force, if you keep Q at this, in between this, the direction of the force remains same, that is same direction. Pulling towards this attraction and away from this. Same direction means equilibrium position is not in between this, because you should have two forces in the opposite direction. Let us keep this near the smaller charge, the earth, away from this, along the same line, plus Q. And observe what is the force acting at this Q by this charge as well as this charge. That is F1 is the electron, that is force acting at this charge by this force, that is attraction. Attraction between this and this, moving in this direction, F1 is the direction. And what is the force acting at this Q or point by this point? That is the repulsive force. The repulsive means it is away, moving away from this point. So the direction of the force, direction forces. The force due to this is this, the force due to this is this, different direction, opposite direction. Then we see that equilibrium position. Somewhere, what is that? Away, not in between. Like that. Let us evaluate what is the equilibrium position in terms of L value. L is the distance of separation between these two. Let us call this as x between these two charges, and this is L. And the force, what is the equilibrium force is net force equals 0, F1 equals F2. When F1 equals to F2, find out, see what is F1. F1 is equal to, that is KQ into 9Q. We should not take minus and plus here, multiply. Q, this into this, 9Q. Divide by distance of separation is this distance and distance, L plus X, whole square, Coulomb square. And what is F2? Again, K into Q. This Q into this Q, where distance of separation is X square. Equate them. That is equated, two forces. And simplify, K, Q, Q cancel. Remaining is 9. Taking this, what is that? That side and this side. That is taking to right hand side. X by L divided by X, whole square is equal to 9. Again, this side, square root of this is equal to 3 plus 3 and minus 3 possible values. Solve for X. That is L is equal to cross multiply, L equals to S. X equals L by 2. Here X equals minus L by 4. If you get minus means not a true value, it is a true value. Plus means L by 2. Plus L by 2. So what is the position of this Q for equilibrium? That is X equals L by 2. The distance of L by 2. It is a equilibrium position, but not in between. It is towards this. What is nearer to the lower, this smaller charge. So this is the X equilibrium. That is the answer for this is L by 2. Equilibrium position of this cube. If there are two charges like this, that is the one we have evaluated. So the problems of this type also important. So with this you have completed the problem set of problems. Thank you.